Have you ever stopped to think about what we use to rebuild the human body when it starts to break down? I mean, when our own biology just isn't enough, science has to step in with some seriously impressive materials. Today, we're doing a deep dive into one of the most important ones, a superalloy that has become the literal backbone of modern surgery.
And let's be honest, it's a tough reality to face. Our bodies can fail us. Joints wear out, bones give way, and the very things that are supposed to hold us up can become our biggest source of pain. This is the core problem, you know? It's what pushes scientists and engineers to find something better, something stronger, something that can outlast what we were born with.
So that really brings us to the big question for this whole explainer. If you have to replace a part of a person, what do you even use? I mean, it's got to be unbelievably strong, right? It has to hold up for decades. And maybe most important of all, the body can't reject it.
Well, for many of the most demanding jobs inside the body, the answer sounds like something straight out of science fiction. It's a high-performance alloy. So let's meet the star of today's show, Cobalt Chrome molybdenum, or as everyone calls it, CoCrmo.
Okay, so what is this stuff really? At its heart, CoCrmo is an absolute powerhouse of a metal. You can think of it as a perfectly engineered recipe designed from the ground up to survive one of the most challenging environments you can imagine, the inside of your body. It's those key traits, strength, wear resistance, and corrosion resistance, that make it a surgeon's best friend. So, where do all these amazing properties come from? Well, like any fantastic recipe, it all comes down to the ingredients. So let's pull back the curtain and look at the anatomy of this bionic building block. Here it is, the precise chemical formula. Cobalt makes up the bulk of it, kind of giving it its core structure. Then you've got chromium, which is the key defender. It provides that incredible resistance to corrosion. And then there's molybdenum. That's the muscle, added to really ramp up the strength and hardness. It's this exact mix that creates something way, way more powerful than any one of these metals alone.
And when you combine those ingredients, you get a material with a legitimate set of superpowers. That chromium creates this passive, protective layer against body fluids. The molybdenum and carbon form these tiny, super hard particles called carbides deep inside the metal structure. That's the real secret to its amazing strength and why it doesn't wear down. And of course, the whole thing is biocompatible, which just means the body says, okay, you can stay.
But here's a twist. Not all CoCrmo is the same. It mostly comes in two flavors. You've got cast, which is just poured into a mold, and then you have wrought, where the metal is forged under intense heat and pressure. And that forging process, wow, it makes a huge difference. Just look at the yield strength. The wrought version is almost twice as strong. That's why it's the top choice for implants that are going to be under a lot of stress.
Okay, so we've got the recipe. We know there are different types. But how do you actually get from a pile of raw metal to a perfectly polished, sterile, life-saving device? Well, that journey is an absolute masterpiece of engineering. The whole process is incredibly intense. It all starts with melting the pure elements in a vacuum, so no impurities can get in. Then, that molten alloy is either cast into a rough shape, or for the high-strength stuff, it's forged. And finally, you have what might be the hardest part, the precision machining and polishing that turns that rough block of metal into a finished implant. And I really want to drive home how tough that last step is. This isn't like carving wood. Because this alloy is so unbelievably hard and doesn't conduct heat well, it's, as this quote puts it, among the most difficult to machine materials. It just shreds cutting tools and requires unbelievable skill to get right.
This visual right here really gets to the core of it all. On the left, you see the smooth, polished implant that a patient receives. But on the right, that's where the magic is. That's the microscopic structure, a dense network of grains and those super hard carbides we talked about. That hidden world is what gives the finished product all of its bionic power.
So, we've gone from the microscopic to the macroscopic. Let's talk about where all this mind-blowing engineering actually ends up. Because of its unique properties, it's become the go-to material for some of the most common and most life-changing implants out there.
I mean, it's everywhere in orthopedics. It's used all the time in high-wear joints like the ball of a hip replacement or the surfaces of a knee replacement because durability is just non-negotiable there. You also see it in spinal rods for stability, in complex dental work, and even in tiny little stents that hold arteries open. It's truly a workhorse of modern medicine.
So how does it really stack up against the other big players in biomaterials? Well, when you look at pure stiffness and strength, it's right up there with stainless steel, but CoCrmo usually wins for joints because it resists wear so much better. Now, titanium is fantastic. It's more flexible and resists corrosion like a champ, but it just doesn't have that raw strength needed for those heavy-duty, high-load joints.
And all of that brings us to the most crucial takeaway.
Co-Chrome gives you strength without size. Think about that. Because it's so incredibly strong, surgeons can use smaller, sleeker implants. For a patient, that can mean a less invasive surgery, a better range of motion, and a more natural feel, all while getting the rock-solid support they need. It's a huge deal.
But of course, no material is a silver bullet. And to give you the full picture, we have to look at the other side of the coin. Because putting any kind of metal alloy inside a human body for years and years, well, it comes with potential challenges and risks. This quote from a study at University College London really sets the stage for the issue. Even though these alloys are designed to be biocompatible, the simple truth is that some people have sensitivities to the metals they're made from, like nickel and sometimes cobalt and chromium too.
And we're not talking about a super rare occurrence. Some studies suggest that as many as 15% of people have some kind of skin hypersensitivity to metals. Now, for most, it's not a big deal. But for a small number, having an implant can kick their immune system into overdrive.
So what's happening here? Well, the main concern is a process called metal ion leaching. Over time, the constant movement and friction on a joint can cause microscopic particles, literally ions of cobalt and chromium, to shed from the implant's surface. And those tiny particles can get into the surrounding tissue and even the bloodstream. And this leaching can, for some patients, lead to a few potential problems that doctors have to watch for very closely. Things like allergic reactions or more severe tissue inflammation. In some rare cases, it can even cause the bone around the implant to weaken, which is a condition called osteolysis. It's so important to remember these are known risks that are always part of the conversation between a doctor and a patient. So when you take a step back and look at the whole story, it's just incredible. It's this perfect marriage of chemistry to create the recipe, intense engineering to forge the part, and medicine to integrate it with our own biology. It really is a powerful testament to our drive to solve some of the body's toughest mechanical problems. And that leaves us with one last question to chew on. We've come so far with this generation of biomaterials, but the work is never finished. As our technology gets better and we understand the human body more deeply, what's coming next? Will we see alloys that are even stronger, or maybe materials that can actively help our bodies heal themselves? That's the exciting frontier we're looking at now.